Hey everyone. So in the previous video, we have been talking about the oxidation of alkenes. We know that for oxidation of alkenes, there were two possible reagents. One is the cold dilute acidified manganate 7. The other was hot and concentrated acidified manganate 7. So the same reactant, but the conditions were different. With cold dilute manganate, we used to break down the pi bond and we used to add two hydroxyl groups on the same carbon. So technically the reactant is almost the same, but there is an addition of two hydroxyl groups on both carbons. But in the hot concentrated conditions, the sigma and pi bond literally split and the whole molecule breaks down into two portions. If the carbon-carbon double bond was on the terminal, you get carbon dioxide. Otherwise, you get either ketones or you get carboxylic acids. If you remember, the hydrogens used to convert into OH group, so carboxylic acid was made, and if there were alkyl groups, they would remain the same. In today's video, we're going to be doing some past paper questions to see how much we have understood. So this question says, an alkene is reacted with acidified manganate 7 ions. The organic product has a relative molecular mass greater than that of the alkene by 34. So the most important thing is product has a relative molecular mass greater than that of alkene. So mass of product is more than the mass of reactant, which means the reactant is not splitting. You are not breaking down the reactant into two products, which means it is the cold dilute condition. Let's look at the option. The first says cold concentrated. We never talked about cold concentrated, it doesn't exist. One of the options says, if you notice, which is our option C, it says hot concentrated does exist. Option D says hot dilute does not exist. So either it's B or C. Now it has to be option B, because in option C the product would be two molecules, so the mass would be lesser. Notice that when you have a carbon-carbon double bond, whatever it is, let's say X, Y, Z, and let's say Q, when you make the product with cold and dilute one, you literally keep everything same. All the groups remain the same on the carbon-carbon bond, but you add two OHs on those carbons. And if you remember, the mass of OH is equals to 17. So two OHs group, when add, they become 32 units of mass. Sorry, 34 units of mass. So technically you are increasing the mass of 34 when you react with cold dilute. Let's look at another MCQ. Which substance forms propanoic acid as one of the products when it reacts with hot concentrated acidified manganate 7? I would suggest making the structure of all these options without the hydrogens obviously, and then figuring out how the product would be made. For option A, it's 4 carbons and there's a carbon-carbon double bond on carbon 1. For butene, again 4 carbons, but the carbon-carbon double bond is in the middle. For option C, propene, and then methyl means so second carbon has a branch. And for option D, it is butene, but1ene basically. So carbon-carbon double bond on position 1 and carbon 2 has a methyl. Let's split these molecules. When you split option A, first portion on the left gives you carbon dioxide because it's a terminal portion, and the second portion, which is on the right, it's a 3 carbon chain which will make propanoic acid. So you will get 3 carbon acid, which is propanoic acid. So definitely option A. But still, for our understanding, let's go for other options. In option B, you split the molecule into two portions, both are 2 carbon each. You get a 2 carbon acid from the left and you get a 2 carbon acid from the right. If you don't remember, How am I so sure about this? You should know that I haven't drawn the hydrogen, remember? So the hydrogens convert themselves into the OH. These hydrogens will convert themselves into the OH. So technically, you will get a carboxylic acid group. Now going for option C, you will split the molecule from here. Since the carbon-carbon double bond is towards the corner, one portion gives you carbon dioxide, while the other portion is a branched portion. So you will get a ketone which has one carbon and then two branches coming out, and that will get oxygen. So this carbon will become the ketonic carbon. When you look at option D, again you split the molecule. From the left you get carbon dioxide, and from the right this is again a branched portion, so you again get a ketone. The carbon will remain the same. It will have two carbons on one side and one carbon towards the bottom, while double bonded oxygen. So this carbon makes the ketone. We get to know that the only option which fits here is option A, because it will give you propanoic acid. Let's go further. A cycloalkane with the molecular formula C7H12 was oxidized by cycloalkene, by the way, was oxidized by hot concentrated acidified manganate. The only product formed was 2-methyl hexane 1,6-dioic acid. The name of the product is really complicated. Let's draw it first. So it says 2-methyl, so carbon number 2 has a methyl and hexane acid. So 6 carbons, 1, 2, 3, 4, 5, 6. Let's number them. 1, 2, 3, 4, 5, 6. Since it's 1,6 hexane dioic acid, which means carbon 1 has a carboxylic acid and carbon 6 has also carboxylic acid. That is why it's dioic acid. There's a methyl on carbon number 2, so a methyl on carbon number 2, and the rest is obviously hydrogen. We know one thing, that the carbons which receive acidic group, carbon 1 and carbon 6 which receive the acidic group, they were actually connected before reaction with manganate. Remember, when we break the carbon-carbon double bond, we actually add acid over there, and that is the product of oxidation. So it means carbon 1 and carbon 6 were connected. So think about the reactant. Carbon 1 and carbon 6 were connected with the double bond in a cycle. 2, 3, 4, 5 were like this. So carbon number 2, 3, 4, 5, 1 and 6 all made a cycle. You know carbon number 2 has a branch, so the branch was already there like this. Now let's talk about the options. The reactant, according to our calculation, has a 6 carbon cycle. So option D is totally wrong. Now option A, B or C. You notice that in our predicted reactant, there's a methyl group on carbon number 2. So if you notice, there's a methyl group one step away from carbon 1. It's not on the double bonded carbon, but it is one carbon away from the double bond. Option B is wrong because the methyl is coming out exactly from the double bond, which is not the case. Option C is also wrong because the methyl is 2 steps away, 1 step away and then 2 steps away from the double bond. So again, option C is wrong. Option A is correct because double bonded carbon has a branch 1 step away. So you can see that option A is exactly what we predicted. Let's go further and do some theory questions. Part C says, give the structural formula of the organic product formed when propene reacts separately with each of the following substances. So we need to draw propene first. This is our propene. We have H's here. We have one H on carbon 2 and three H's on carbon 3. Carbon number 1, 2, 3. When you react it with bromine, which is Br2, we know that both carbons receive one atom each. There is no major and minor product here because both carbons will receive bromine. Draw the exact structure. Don't change the reactant. Just remove the pi bond. One carbon gets one bromine atom, another gets other bromine atom. For the cold dilute manganate 7, we know we keep the reactant same, just that we add OHs. So I'll make the same structure. Carbon 3 has 3 hydrogens. Pi bond goes away. You will add one OH on carbon number 2, one OH on carbon 1. Both carbons which had the double bond, which is the red and yellow carbon, I'll make the other products also red and yellow for us to remember how we are doing it. So they both get OH. For the reaction with hot concentrated, we know we have to break the carbon-carbon bonds, both the bonds, double bond, including sigma and pi both. So you will split the molecule like this. The portion on the right is literally one carbon. So you will get carbon dioxide. So first product is carbon dioxide. And from the red carbon, you can see there is a methyl coming out. So you can see one methyl is coming out, so keep it that way. And what about the H? The H converts itself into the OH, and instead of the double bond, you make a bond with oxygen. So this is the other structure. Technically, this is ethanoic acid that you receive here. Instead of the carbon-carbon double bond, you make a bond with oxygen, and instead of the H, which was on the top, you made OH. This question seems tricky. It says absorption Y shows that L has a carbon-carbon double bond present in the R group. The student decided to treat L with hot concentrated acidified potassium manganate 7. The products of the reaction are shown. So there's a reactant L. It has a R group which has the double bond, and then we are converting it into products by reaction with hot acidified manganate. You can see that the 5 carbon cycle with the oxygen remains the same. It's the same in one of the products, but the R group has converted itself into this portion and this portion. So it means the R group had all these carbons. Now let's number it to understand how the R group looked like. I would number it in a way. Let's call this carbon 1 and this carbon 2. What about the M? Let's number it also. You can see M has a carboxylic acid group and there are 4 CH2s. So CH2, 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 CH2 and then CH3. Let's number it. Carbon 4, 5, 6, 7, 8, 9. We are not numbering it for naming, right? So that's okay even if our numbering is not exactly, because IUPAC we are not naming it. We are just doing it for the sake of understanding. You can notice that carbon 1 has gotten the oxygen double bond and carbon 4 has gotten the oxygen double bond, because technically if you notice, this is what carbon 4 looks like. So carbon 4 gets the oxygen double bond. Let me label it carbon 4, and carbon 1 has it. It gives us a knowledge that carbon 1 and carbon 4 were connected. Carbon 1 and carbon 4 were actually connected. Now notice what was on side of carbon 1. It was a carbon, which is carbon 2. So it must have been a CH3. Also notice what was with carbon number 4. It was this whole chain, which was carbon 5, 6, 7, 8, 9. So it was this whole chain which was CH2 4 times, CH2, 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 so CH2 4 times, and then CH3. Since both are becoming acids, you can see both are becoming acids. It means carbon 1 had H and carbon 4 also had H. So R group was actually this. This was the R group. When we draw it in a way, we get R is equals to CH3 from the left. Then there was a carbon-carbon double bond, so CH, CH, and then this whole group, CH2 4 times, and then CH3. They were asking for the name of M, by the way, so let me remove this and let's name M. M is a carboxylic acid with 6 carbons, carbon 1, and then we know 2, 3, 4, 5 because it's a chain of 4, and then CH3. So it was hexanoic acid. Hexanoic acid. By the way, this was the R group. It was a little tricky, but you can notice it's only one mark. So my suggestion is that try to do the whole structure in your head and just remember to connect the double bonded carbon together and then read the rest of the structure. It will help you understanding how the product was made. Let's do this question. It says butadiene is an important compound in the petrochemical industry. Some reactions of butadiene are given below. In each box, draw the structural formula. Okay. First they want us addition of steam. So everything remains the same from the left, CH3. I'm starting from the left, by the way. Then you can see a CH2. Then the CH and then CH2, right? Markovnikov rule tells us that from the water there's H and OH. So the H will go to the carbon with more H's. Carbon number 1 has more H's while carbon number 2 has less H's and it has more branches. So Markovnikov rule tells us that H will go on the carbon with less branches and you can say more hydrogens. So H will go here and OH will go here. So we will write the structure in a way that it becomes CHOH in the bracket because it's a branch, and then carbon 1 is CH3. So your carbon 1 gets the CH3 and then carbon 2 gets OH. The next portion asks us for cold dilute. So we know for cold dilute we don't do anything extra. We do the whole structure exactly the same and we add OH. So both carbons receive one OH like this. Carbon number 1 gets OH and carbon number 2 gets OH. Let's do hot concentrated. In hot concentrated we break down the molecule, right? So you can see that from the left there's a CH2. So the CH2 will produce carbon dioxide gas, and the rest of the structure which is on the left side is a 3 carbon portion. So this 3 carbon portion will give you propanoic acid. So you will get propanoic acid like this. Because it's an unbranched 3 carbon chain, so the double bond goes away and you get oxygen attached because of the manganate. I hope you guys are getting these ideas. I will be uploading these files on the YouTube description to help you assist in your preparations. Stay tuned guys. Thanks.